So I have picked out the different addressing modes we're going to use. I've also made a slight change to the circuit here. And also we've actually got more space available than I had mentioned yesterday when I talked about the addressing modes. So first of all, we've got our 6 bits here, which is our opcode. So our 6 bits going to give us 2 to the power of 6. So 2 to the power of 6 is 64. So we're going to have 64 different individual instructions that we can have. But we're going to have these other 2 bits here, which is going to give us 2 to the power of 2, which is going to be a value of 4. So we're going to have the 4 different addressing modes for those 64 different instructions. So we're going to have plenty of space there for those instructions, all the instructions we want and all of the addressing modes we want. Because in the end we're going to have the 2 to the power of 6, or if you count these 2 here, it would be 2 to the power of 8, which is 256. So all of the instructions and all of the addressing modes for those instructions would give us a maximum of 256 individual instruction types that we could use. Now we're not going to use all of those, and in fact it looks like we'll probably have about another 5 or 6 instructions, so we'll probably have around about 30 instructions that we can use. Now there could be a maximum of 4 addressing modes for each of those instructions, so we could have 4 times 30, which is about 120. So we would have absolute maximum about 120 individual instructions that we can use in the chip. Of course we will have less than that, because not all of the instructions are going to have 4 addressing modes associated with them. Some of them just won't make any sense, and also some of the instructions won't really make any sense. So we're going to have at maximum 120, but probably we won't be using all of those. Now I also decided when we begin here, you'll see I changed this slightly. So rather than having, as I mentioned yesterday, blocks of addressing modes, so we would have one addressing mode in one block and then another addressing mode in another block within this, the microcoded compression and also the ROM. Rather than doing it like that, I think it's smarter if we just do them one after the other. So for example, if we had an add instruction and we generated the add instruction in 4 different addressing modes, then those are going to sit in this position, this position, here, and this one, and then this one. So that would give us the 4 different add addressing mode instructions, and all we need to do is add the value of 0, 1, 2 and 3 on from the choice of addressing modes, and then we can move up to the next one. So the opcode here will give us the next address up, and then we'll add on 1, 2, 3 and 4. Okay, so again I'll have to adjust this opcode slightly so it does that, but that's no big deal, we can make that work. But that's the idea. We're going to have 4 in a row, and then another 4 and another 4 and another 4, and so on and so forth. Now I looked through the addressing modes and I covered 8 different addressing modes, and in fact there's lots and lots of different ones, and you could do this to death and pull out lots of weird and wonderful ways in order to address your memory or find the operand position within your memory. And I covered 8 basic ones here. Now I'll just mention them here and I'll talk more about them in the course, but the ones I looked at were immediate addressing, direct, indexed, indirect, pre-indexed, indirect, post-index, indirect, and there was a register direct and register indirect. And as I said, the actual instructions that we have at the moment, they're a mixture of some of these. Okay, so they're all just kind of mixed up. Now I picked out 4 of these, and the 4 I've picked out, I've actually got my workings here. So the 4 that I picked out, if I can find them here, are the immediate, direct, indexed, and indirect. So those are the 4 addressing modes I'm going to pick out, and there's a reason for picking those 4 out, but I will get into that in more detail in the course. Now, one other thing is that there's one of the options that I chose, which is an indexed addressing, and part of the reason why I chose that as well is because it actually it gives us another addressing mode, which is a subset of that. So we get 2 for the price of 1. So whenever we pick an indexed addressing mode, we get a register addressing mode as well. All we do is just set the index to 0, and then it becomes the register addressing mode. So a lot of this might not make a lot of sense to you until you've covered addressing modes. But in BASIC, we picked out 4 addressing modes, but we actually get 5, which is a bonus. Now, I think what I'll do is I'll just quickly go through the addressing modes I've chosen, just so you can see roughly what they are. I mean, there's nothing, it's not rocket science or anything. Let's see, I'll bring up the smooth draw, take that one off. Okay, and that's you should be able to see. So they're all going to look similar. Okay, so for example, we're going to have an immediate addressing mode. So that would be, and forgive the writing, because when I write in this, I'm not very neat and tidy. But I'm going to have something along the line of load and hash. Now hash just means the actual value, 10, R1. Now we know that the load command takes information from the memory to a register, but in this instance here, it's not actually getting it from the memory, it's just getting the value here from this literal value 10. So the way that this is actually going to work is we're going to have the load RARB, which is going to be a 16-bit instruction. So we've got 16 bits for that. And the value here for the number we want to actually load into this register RA is going to come from the next address. Okay, so I mean it's coming from the next byte in memory. So we've got that next byte in memory, which is going to contain this number 10. Okay, so that's why it's called an immediate, because the number, the operand that we're going to be shifting is going to come from the address or the location, the memory location straight after the instruction. So it's immediately after the instruction. That's why we call it the immediate mode. We could also have it where the value for 10 would actually sit within the instruction code itself, and then the value would be immediately after the opcode. Okay, but we don't have space here to do that. Okay, so we're going to put it into the next address in memory. So that's the immediate one, and the other one we're going to look at here is going to be load, say 500, RA, and this is going to be our direct addressing mode. So in this instance here, the 500 doesn't refer to an actual number. 500 refers to a memory location. So we're going to load the value that sits in memory location 500 into the register given via RA. Now that's going to be the direct. Now I might change some of these. We can always change that to RB if we wanted to. You know, we can swap them around about, but it doesn't really matter for the moment. We can just leave it like this. Okay. So that's going to be the direct method. Now, the next one that we look at is going to be an indexed method. Okay, so we could have, if we had, for example, load the value R1, comma, and we'll put this in brackets, so we have our R2, that's a 2 there, R2 plus 5, and this is our indexed. So what we do is we go to a memory location given by this here. Okay, so that shouldn't be say R2, it's just, we can just put an RA because it could be anything. So we go to this memory location and then load the value in this memory location into register R1. Now, to get to the memory location, we go to the contents of register RA. Okay, so the contents of register RA will contain an address. We go to that address in memory, but we don't get our information from that address. We then add 5 onto it, and we go to the 5th one down from it, and we pull out our operand from there, and we take that and then we place it into the register R1. So that's just called the indexing. Now, this indexing one was the one that was quite useful, because if we made this index a value of 0, then all we're going to have is, for example, we could make that, so it says R1, but it should actually say RA. But we made it RA, and we could make that one RB. Okay, if that's RA, and we could make that RB. Then we're going to have the register direct. So, and we've seen this one before. This was what our normal load command would look like. It would say load the load into register RA the contents of the memory location pointed to by register RB, and we can get it indexed by just adding 5 onto it. So that gives us 2 possible addressing modes in one. Now, the other one is going to be the indirect. Okay, so this is going to be load, and we could have RA, comma, and I'll put it in brackets, RB, and this is going to be indirect. Now, what we're going to do is we're going to load into the register RA the memory location here, okay, but this here contains an address of a memory location. But when we get to that memory location, what's inside it is a pointer, and that pointer is basically another number, and that number points to the actual memory location that we're going to get our value from. Okay, so a bit awkward to describe there, but those are our 4 basic fundamental addressing modes that we're going to use, and we can use those addressing modes for pretty much most of the instructions that we have. Of course, there's some instructions we don't need to use all those addressing modes for, okay, but that doesn't matter. It's as long as we can use it for most of them, and that's as much as we're going to do here on addressing modes. So I'm going to crack on and change the circuit a little bit so that we can make sure we can pick out the addressing modes properly within the microcoded ROM, and then fix all of the addressing modes in within the spreadsheet. So you'll have seen the spreadsheet before. So I'll have to get into this spreadsheet here and fix all of the different values here for the addressing mode. So I'll take a day or so to go through and update this and check them out and make sure they're actually all working. So that's as far as I've got today, and the next day or so, again, we'll get most of this finished, and hopefully we won't have to spend any more time on the control unit, although the control unit really is the heart of the entire CPU, and you can see that I have spent a long time messing about with it, because if you mess about with it, it really defines what your CPU is and how it works and what it can do. And I suppose it is actually quite interesting. Right, that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.